Hello, everyone. I'm Connor Mayer, and on behalf of my co-authors Chenhao Chu and Brian Jick, I'm going to talk to you about biomechanical simulation of lip compression and spreading. So researchers have proposed that speech exploits quantal properties of the vocal tract. And what we mean by quantal is just a function where large differences in some input variable result in relatively small differences in some output variable. And there's two types of quantality that have been discussed with respect to speech. The first is acoustic quantality, whereby large differences in articulator position result in relatively minor differences in acoustics. This is demonstrated by the graph on the right, where regions 1 and regions 3 are strongly quantal. The second type is biomechanical quantality, where large differences in muscle activation result in relatively small differences in articulator position. And Fujimura predicted this relationship to exist for postures of the lips used in speech. And indeed, biomechanical simulation studies have found quantal effects for various labial movements used in speech, including rounding, closure, and labiodental constriction. There are two prevalent labial postures in speech that have not been studied from this perspective, though, and these are lip spreading, where the corners of the lips are drawn back, as in English E, and lip compression, where lip aperture is narrowed but without much accompanying protrusion, as in Mandarin E. So the goals of the current study are to identify what muscle groupings are sufficient to drive lip spreading and compression, and to check whether these groupings display quantal properties as we might predict. The way that we did this was using a biomechanical model of the face and lips implemented in ArtiSynth. We identified muscle groupings and relative maximum activation levels of each muscle that were sufficient to produce appropriate postures. We then activated these groupings from 0 to 100% of the maximum activation level and measured lip opening along the way. In our results for spreading, we found that the buccinator alone is sufficient to produce this lip posture. And you can see in the upper 50% of the activation range, we get a relatively stable lip aperture. So this is a fairly quantal kind of movement. Our results for compression rely on a larger set of muscles, and in particular, there's a pair of muscles in red here that serve to reduce lip aperture and a set of muscles in green that serve to increase it, and the interaction between these two sets of muscles produces lip compression. And you can see that although this graph isn't as quantal as the previous one, we still have a nice region of stability in the upper 25% of the activation range. So in conclusion, the muscle groupings that drive lip spreading rely primarily on the buccinator, where compression involves this interaction between muscles that close the lips and muscles that open them. And these results are broadly consistent with the experimental literature, although there are some differences that are interesting, but I don't have time to go into here. Our second question, do these groupings display quantal properties? The answer is yes. And this supports the claim that speech movements exploit regions of biomechanical stability. Thank you.